Welcome back again, everyone. We are now on page number 104, and I'm feeling like I need a new color. What color do I want to use? I haven't used green at all, but I don't know if I like that color green. But we'll give this color green a try. How's that? Okay, so let me go to my palette here. Here's my color green. We'll see how I like it. All right, so we're now on page number 104 in our notes book. Let's do some more practice naming ionic compounds. All right, so we're going to star each formula that requires a Roman numeral in its chemical name. All right, so that's the first thing I want to go through and do. So how do I know if something needs a Roman numeral or not? I'm going to look at my handy dandy reference table, my periodic table. If it's in the transition metal groups between 3 and 12, and there's more than one oxidation state, right, which is the number in the upper right-hand corner, you need a Roman numeral. If it's in the transition metal neighborhood and there's only one oxidation state, you don't need a Roman numeral. Anything over here in group 1 or group 2 does not need a Roman numeral because group 1 and group 2 metals can only be +1 or +2. So it's only when there's a multiple oxidation state. So then I'm going to put a star here, and I'm going to put a star number here. So if I look over here, calcium is in group number 2, no Roman numeral. Group number 1, no Roman numeral. Group 1, group 2. Now look for zinc. All right. Oh, zinc is in group number 12. Does it have more than one oxidation state? Nope, it only has one oxidation state, so no Roman numeral. All right, so then I have a polyatomic ion here. So that's not even a metal from the periodic table, so I do not need one. Aluminum is right here. That only has one oxidation state, so no Roman numeral. Copper, definitely. Right in the center of the transition metal neighborhood and more than one oxidation state. Sodium is in group 1, calcium's in group 2. Iron definitely needs a Roman numeral. It's in the transition metal neighborhood on the periodic table, and it has more than one charge. 2 polyatomic ions, no. And number 15, sodium is in group 1. Manganese, double check, there it is, right there in group number 7, and it has more than one charge. Manganese definitely needs a Roman numeral. Magnesium, however, does not. That's in group number 2. We already established that copper does. Sodium's in group number 1. All right, so I starred our formulas that need a Roman numeral. Now we're going to circle all the polyatomic ions, which remember, if I have poly, that means I'm going to have 2 or more elements in my formula. Because if it's only 2, then like this one, we call this one a binary compound. So if it has more than 2 elements, it's going to have a polyatomic ion. So, and I need to circle it. And so I want to find what matches on table E of your reference tables, right? We need table E and your periodic table for these things. So now I'm going to circle my polyatomic ion here. That's binary, no circling needed. So now I'm going to circle my sulfate. I'm circling what I find on table E. And then 4 and 5 are binary. 6 is a binary. 7, I definitely need to circle. This one's easy because I just circle whatever's inside those parentheses. That makes my life easier. Now I've got 4 different elements. Here are actually 3 different elements, but 4 symbols here. So I'm going to circle what I find on table E. So I have an NH4 and the NO3. Oh, this one makes it easy for me because it's right there in the parentheses. This one, and I'm circling this one from table E, and I'm going to circle this. Because remember, you're just looking for the matches right now on table E, binary, so I don't need to circle anything. This one's in my parentheses already, so that makes it easy. And then I circle that, right? Both of those are listed on table E. And then now I have this HSO4. Careful, there's SO4 on table E and also HSO4 on table E. Right? I'm circling what I find the matches for on table E. Number 16 is binary, no circling. And now here I'm going to have the parentheses. They make it easy for me. And circle that. And find what I need to circle from table E. Find what I need to circle on table E, being very careful because carbonate is there, CO3, but I want the HCO3, which is hydrogen carbonate. So now let's go, what is the next thing I need to do? Now we're just going to write the chemical name for each. And then we'll remember the ones that we starred. That means we have to use a Roman numeral. And then we'll remember the ones that we do the circles around, which means that we're going to have to use table E. Right, so then I always name the metal first, keeping its full name. This is calcium. And now since I know I need to use table E, I'm going to go to table E, and I'm going to copy down the name exactly as appears on table E, no changing the names endings to "ide" on table E. This is carbonate. So that's calcium carbonate. This is potassium. And I only have 2 elements, so this is a binary compound. So the nonmetal is going to have to change the name, and we're going to change the nonmetal's name to end in "ide." So then chlorine becomes chloride. This potassium chloride. So now I know I need a Roman numeral, and I know I need table E. So then I'm going to name Fe, iron. And I know I'm going to need a Roman numeral, so I'm going to kind of put that there. And then I'm going to find SO4, and that is sulfate from table E. So I need to know what the Roman numeral is. I have to figure it out based on the negative charge. Negative charge is -2. You're always, always, always know the negative charge because the nonmetals charges are negative on the periodic table, and table E has the charges. So then if this sulfate is -2, I have 1 iron, so it must be a +2. So then that becomes Roman numeral 2. All right, so binary compound, no table E, no Roman numeral. So the metal gets its full name, that's lithium. And then bromine becomes bromide. So lithium bromide. Let's just give myself a little bit more space here. Okay, and so now I have binary magnesium. Right, the metal keeps its name. And then chlorine becomes chloride. So magnesium chloride. Now I need a Roman numeral, so I'm going to name the metal first. So Fe is iron. I know I need a Roman numeral, so I'm going to put that in parentheses. And then chlorine becomes chloride. So I need to figure out what this Roman numeral is. You always know the negative charge. According to the periodic table, chlorine is a -1 charge. I have 3 -1s. So the total negative charge of this compound is -3. So then my 1 iron over here must balance that out with a +3. The Roman numeral tells you the oxidation state of the metal. So that's Roman numeral 3. Right? I can also grab it by doing a reverse crisscross and pull that 3 over there. So now I'm going to do zinc. And now I'm going to find this on table E, and that is phosphate. And so now over here, I have NH4 and NO3. So I need to name these both using table E. This is ammonium. And then nitrate. So now I'm going to go here. Aluminum keeps its name. And I'm going to go to table E. I'm going to find the OH and copy down the name from table E, and that's hydroxide. So now I know I need a Roman numeral, and I know I need to use table E. So I have copper. And I know I need a Roman numeral, so I'll leave a little space for it. And I'm going to copy down the name that appears on table E for C2H3O2, and that is acetate. And now I need to figure out what the Roman numeral is. So I need the charge of that acetate. What number am I on? I'm on number 2. So then the acetate is a -1 charge. And so that means that this copper is a +1 charge. So I can give that a Roman numeral 1. So now I have the element sodium, no Roman numeral needed. And then I'm going to find this on table E, and then that is chlorite. Remember, it's not chloride and it is not chlorate, it is chlorite. Differs only by 1 letter, all of those 3. So make sure you're very careful. And be careful with your handwriting too, especially because we don't want the IDE or we don't want ATE. So now I've got calcium. And C2O4, I'm going to find that on table E, and that is oxalate. And that got messy, so I'm going to erase that. Come on, eraser, you can do it. Erase. There we go. I get impatient when the technology tools don't work the way I want them to. So oxalate. All right, so next one. Let's just scroll down here a little bit. Whoops. Wow, that was a little bit too fast, too crazy. Sorry, didn't mean to make you dizzy. Okay, so I know I need a Roman numeral. So Fe is iron. I know I need a Roman numeral, so give myself some space. Oxygen is a nonmetal on periodic table, so it becomes oxide. Now I need to figure out what the Roman numeral is. The quick, cheat way is to just grab this number over here, and that's Roman numeral 3. And it's correct. But let's go through the process mathematically to kind of figure it out. You always know what the negative charge is. Oxygen is a -2 charge. I have 3 oxygens. So 3 times -2 means that the total negative charge in this compound is -6. That means on the other side, the total positive charge has to equal +6, right? Because all compounds are electrically neutral. But I have 2 irons that have to add up to that +6. So each individual iron is a +3, hence Roman numeral 3. All right, 2 things from table E. I'm just going to copy their names right down from table E. Even though it looks more complicated, it's actually pretty easy. Ammonium, and then phosphate. The Roman numeral ones are the trickiest. Roman numerals and table E, that's probably even trickier, right? So I have sodium, and I'm going to find HSO4, and that's hydrogen sulfate. It's not sodium sulfate because that would be without the hydrogen. So making sure you're reading carefully and examining both the reference tape, the periodic table, and table E very carefully. I know I need a Roman numeral, so manganese, and I'm going to leave my space for my Roman numeral, and that's phosphorus, so that's going to become phosphide, not phosphate, because that would be p104. And now I need to figure out what the charge is. Well, I probably can reverse crisscross this and grab that too. And you would be correct. But let's see, does it make sense mathematically? So we always have the negative charge for the nonmetal on table E, -3. If I have 2 -3s, that's a -6 total negative charge for this compound. So the manganese has to be a total charge of +6. So I have 3 manganese. So each individual manganese must be a +2. Again, so the reverse crisscross worked here. So now I have magnesium. Careful with the magnesium and manganese, reading carefully, writing carefully and clearly. And then I need to go to table E, and this is nitrate, and just copy that down. I know I need a Roman numeral, and I know I need table E. So copper, and then sulfate. And then I'm going to put my parentheses right here, and then I have sulfate. So then do I reverse crisscross? Is it going to be a 1? I like to do this with math, and I like to check it. I like to check it out. So the sulfate is a -2 charge on table E. So then copper must be a +2 charge. And so since there was just 1 and 1, right? Because if I were to crisscross and I would do a 2 and a 2, that would have to reduce to a 1 and a 1 anyway. So that's why there's no 2's there. So this is actually copper Roman numeral 2, right? When you do a reverse crisscross, use that number and try and do the math and make sure you're correct. All right, so I have sodium, right? Math will never lead you astray. And then HCO3, hydrogen carbonate, not carbonate, hydrogen carbonate. All right, so good job. All right, I'm gonna just go through and I'm going to go through and I'm going to do page 105 at the same time, because even though I wanted to make this, I don't necessarily want to make this video longer than it needs to be, but it's time for me to start wrapping things up. And we're just going to move on to page 105. Right, we're going to talk about hydrates and we're going to name our hydrates. Okay, so I have potassium, and by now you should be able to name this part with no problem. Potassium nitrate, no Roman numeral needed because potassium's in group number 1. And now I need to name this .5H2O, right? This dot means that the water is attached or absorbed into the potassium nitrate crystal, and there's 5 of them. And so this is going to be potassium nitrate and then pentahydrate, right? Because hydrate means water. And so now here I have iron, and I know iron's in a transition metal neighborhood, so it needs a Roman numeral. I'm probably going to just use this as my Roman numeral, reverse crisscross, Roman numeral 3, nitrate. And it also does work out because the nitrate is a -1, and then that means that's a +3, Roman numeral 3. And now I have 3, so then that would be trihydrate. And now I have magnesium. And then SO3 is sulfite, right? So magnesium sulfite. And then hydrate. Monohydrate, sorry. Right, because prefix mono meaning 1. And now here I have gold. And this is going to be gold, Roman numeral 3, sulfate. Right, and I knew that. I grabbed that 3, and then I used the math to make sure that I'm correct. Right, so I have -3 times -2, -6. So that means the gold has to equal up to be +6. And so each gold is a +3. So 7 is heptahydrate. And now I have sodium. Oh, erase. Right, it's starting to get a little bit messy, right? Too much writing today, guys, so I'm getting a little messier here. Okay, sodium. And then that is NO3 is nitrate. And then 4, I believe, is quatrahydrate. Right, we have mono, di, tri, and then I think that's quatrahydrate. I could be wrong, but, or is it tetra? I'm going to have to just make sure. I want to double check, because sometimes I second guess myself. So I just want to make sure that I double check on our hydrates. Alrighty. Hold on. Let me just check on this right here. Sorry, guys. Don't mind here. 4. Yep. Sorry, tetra. Oops. Let me screen share. You don't want this screen. I need to go back to my other screen here. Okay, so it is tetrahydrate. Sorry, guys, it's not quadrahydrate. I was thinking more Latin at the time. Okay, tetrahydrate. Okay, so now I need to write the formula, symbols, charges, crisscross, and now we're going to do dot hydrates. Okay, so I have Mg for magnesium, sulfate, SO4. My charges, +2 for the magnesium from the periodic table, -2 from table E. So it's MgS4. And now I need to attach the pent, meaning 5, hydrate, meaning waters. So 5H2O. Right? You have to have the dot. If you just stuck that on there, and wrote it all in a row, you wouldn't be indicating that the water is attached to the molecule. So now we have copper, Roman numeral 1 phosphate, so that's copper, and then p104. Roman numeral 1 means that the copper is +1 and the phosphate is going to be -3, so I need a subscript of 3 here. And then trihydrate, 3H2O. Gallium oxide monohydrate, so Ga for gallium, O for oxide. Let's get our oxidation states. Gallium's a +3 and oxygen's a -2. So then I'll need a 3 for the oxygen and a 2 for the gallium. So I need a 2 and a 3. And now I need to attach one water molecule and H2O. You could also put the 1 in front, but chemists generally don't use 1s when we can avoid them, because when you write H2O, there is 1. So you don't have to do 1. It's like saying 1, 1. Okay, so manganese, Mn. And then sulfide means it's the element sulfur, right? This manganese is going to be a +4 charge, and the sulfur is a -2. So when you crisscross them, right? So I'm just going to do that down here. Mn, not MM, Mn, and then S. I have a +4 and a -2. So then I bring a 4 and a 2. And so 2 and 4 both can be reduced. So MnS2. So MnS2. And then I have a dihydrate. Oops, I'm not writing the word di. See, I'm getting tired. This is what happens. And if you're still sticking with me, that's great. Okay. And so then it's going to be di, meaning 2 hydrate, H2O. All right, so thallium, so that's TH. Roman numeral 1 means it's a +1. Fluoride is a -1. So then thallium, fluoride. And then I have tetra, meaning 4, hydrate, H2O. So then that is our hydrates. All right, so working with the hydrates, let's come up with, we already did a couple of names of hydrates. All right, so let's just go through our next one, and I believe this is going to be the last video, the last portion of this video, if you're still with me. All right, so I have calcium, sulfate, and I have dihydrate. And you know what, I'm doing hydrates. I feel like I should do a nice little blue, like a little aqua here. All right, so I have magnesium, bromide. Now I have 6, so 6 is hexahydrate. Now I have ammonium, so that is NH4, sulfate, SO4, charges, +1, -2. So I have to put the parentheses in here. And I'm so I don't have to rewrite it, I'm just going to erase my charges. There we go. And now I'm going to do my dot, and then I have monohydrate. So dot H2O. So I have sodium, carbonate, and then I have trihydrate. Okay, so now I have cobalt, so I have CO, and I have chloride, Cl. Right, now I need my charges. I have cobalt as a +2 because the Roman numeral 2 says so, and a -1. So when I do my crisscross, I need 2 of those chlorines, so cobalt chloride. And hex meaning 6 hydrates, H2O. Now magnesium, symbols, and then sulfate, so 4. Charges, magnesium is a +2, sulfate is a -2, so that's good. And now I'm going to do my dot, and now hept is 7, and then hydrate water. Now over here, I have magnesium, chloride, and I have 6-hexahydrate. Copper, Cu, and chlorine, Cl. Positive 1 because the Roman numeral 1 says it is, -1 because the periodic table says it is. So that's just Cu, Cl, and then dihydrate, and that is 2 waters. So now I'm going to name this one. This is lead. I know I need a Roman numeral because lead has more than one oxidation state, and it's in the periodic table center area, the transition metals. So I need to know what the Roman numeral is. So I'm going to go over here and I'm going to grab that subscript of 2. So lead, Roman numeral 2. And then I'm just going to double check if that works, right? I know the acetate is a -1, and sorry, this is also acetate. And I know the acetate is -1, so if I have 2 times -1, that's -2. So then lead is +2, and yep, that works for my Roman numeral 2. And then I'm going to do my dot, and then trihydrate. And now I have iron is Fe, and Cl for chlorine. Iron's a +3, and then because the Roman numeral 3 tells me it is, and chlorine is -1 from the periodic table. So when you crisscross, I'm going to need 3 of those chlorines and 1 iron. Right, the Roman numeral often ends up on the other side, 90% of the time. And then I'm going to do my dot. So I have and tetra, meaning 4, and then hydrate, meaning H2O. All right, so that is going to wrap up a lot of the practice in this unit. You should still keep practicing. Thanks for joining me.